Hello everybody, this is Zero Day, and this is the first scenario in the Cloudgoat series. You start off as a low-privileged user named Bilbo who can perform IAM get and IAM list on all resources. After enumerating the cloud infrastructure, you find that there is a role that you could actually assume, and with this role, you could actually invoke the vulnerable Lambda function. You find that there's actually an SQL injection vulnerability in the Lambda function. And as it turns out, it's quite handy that this vulnerable Lambda function has the IAM attach user policy permissions on the Bilbo user. So after exporting the Lambda function, you could actually attach the administrator access managed policy to your user and essentially become an administrator. We were provided the credentials of the first user, Bilbo. This is the access key, the secret key. So let's just put that in. I'm just going to configure it. Let's call him Bilbo because that's his name. And we can put this as his access key and this as his secret key. And we'll keep the default region as US East 1. And okay, so now we are the Bilbo user. So the first thing that we should try is just to enumerate the permissions of this user. So we could do that with the IAM. And let's list the attached user policies of this user. So we need the username, and to get that, let's just do the caller identity, which is basically like who am I, but for AWS. Forgot to put Bilbo here. And we see that this is the username. So let's just put that here, and we are the Bilbo user. I'm just gonna close this so it's bigger. We see there are no attached user policies. Now what this looks for is the managed policies. Well, maybe the Bilbo user doesn't have managed policies. As we can see, there actually aren't any, but it is possible that there are inline policies for this user, for this particular identity to be exact. And we could do that with the list user policies command. So the main difference between list user policies and list attached user policies is this looks for managed policies, and this looks for inline policies. So this is the inline policy of the Bilbo user. So we can just get that policy and provide the IAM module and the policy ARN. So get-policy actually looks for the managed policies, and as we figured out, there's actually no managed policies associated with the user. So what we do instead is get-user-policy, and then this looks at the inline policies. Inline policy is just a policy that's embedded in the identity of the user. So two users cannot have the same inline policy. The inline policy might have the same permissions, but it's not the same exact policy. Usually because of that, managed policies are used instead of inline policies in a real environment. Because with a managed policy, you can just change a certain permission of the policy, and all the users who have that policy are affected. This way, with an identity policy, if everybody has the same permissions for their specific identity, if you wanted to change the permissions for every user, you'd have to manually go and change that. So let's provide the username, which we found was CG Bilbo, all of this. And the policy name, which if we go back up here, it was this. This is the inline policy. And these are all the permissions for the Bilbo user. We can see that the Bilbo user can do any get commands for any resource, and it can list anything for any resource. This is specifically for IAM. It could also simulate the custom policy or simulate a principal policy. This is not really interesting. These two are just used for simulating permissions of a user. So it can't even create API calls. It just tells you if you have permissions to do something or not. They're not real API calls. Okay, so we can see this, but we can't escalate privileges with these permissions alone. But because we do have this list permission, we should start trying to list maybe roles that are in this cloud infrastructure. Because maybe there is some role that we can assume. So if we do this command, we see here there's a lot to see, but this is just a default AWS policy roles. These are just AWS roles. These aren't customer managed or anything, but if we look further down, we see these two roles, which are quite interesting, this one and this one. So if we look at this role, we see that the Bilbo user, which is right here, is allowed to do this command, this sts assume role command. And this vulnerable Lambda function, it's quite convenient that they say that it's a vulnerable, but this vulnerable function can only be assumed from another Lambda function. So, okay, let's first just assume this role, and the reason we're able to is because we are this user. So let's just assume this role right here. So AWS sts assume dash role, and let's just put our profile, and we need the role ARN and the role dash session dash name. So this is the name right here, which we copied, and the role ARN, let's just copy that up here. And we receive the credentials of this Lambda function so that we can actually assume it. So let's configure a profile, let's call it Lambda, and let's put these credentials. Now note that there's also this session token credential right here, but the AWS configure profile command did not ask for a session token. Now we need this. If I show you right here, dash profile Lambda, it says the security token included in the request is invalid. Well, the reason is because we did not put the session token in. So what you can do is you can just go into your credentials file. Now I won't do that here because I have some credentials in there that I don't want, that are kind of secret. So let's just put the session token using an echo command. So AWS underscore session underscore token equals all of this. And let's put that there, and let's put that at the end of the credentials file. Okay, so now that we have that in there, we can do the same command. AWS sts get dash caller dash identity profile Lambda. And now that worked. We didn't get that error. Okay, so what can we even do with this role? So remember that we were looking at the inline policies of the Bilbo user. Now there's something that's just like that for users, but except for roles. So now that we are this role, let's look at what the inline policies are for this role. And we would do that with this command, list-role-policies, and let's put the role name, which is, here, I'll just run that command really quick. AWS IAM list-roles, profile Bilbo. The role name was this. And what was the other one that it asked for? Oh, just the role name. Okay, right, because it's just the list role policies command. And this is the inline policy associated with this role. Now before we look at what that is, let's look at what the managed policies are of this. So we would do that with list-attached role-policies. And we see there are no managed policies associated with this Lambda function. So just like with the user, there was an inline policy, but not a managed policy. So let's try to get this policy. So AWS IAM get-role-policy. Let's put our profile there. And it asks for a role name and a policy name. So let's put our role name of this. And the policy name we see right here is Lambda-invoker. And we see that these are all the permissions of the Lambda function, or the Lambda role that we assumed. So we can list tags. We can invoke functions. This is particularly interesting. And we can get functions. So with the get functions command, you can actually get the code associated with a Lambda function, which is typically Python. You have the BOTO3 module. You can also get policies, Lambda get policy, and we have this list function event. So you can perform all of these commands on these specific resources on the vulnerable function that we saw earlier. But also you can list functions for all resources, so that's not just for this function. And you can do an IAM get, IAM list, and basically you have all the permissions of the IAM Bilbo user, and you have these assumed role, and which makes sense because we are the Bilbo user, so that's why we have these permissions. But we also have these extra permissions right here from the role that we assumed. So let's just get this function. Let's see. Before we try to even exploit this function, let's see if it's even worth it. Are there permissions associated with this function that we don't even have? So this is the role name. Let's copy that. And let's do the same thing we just did with our assumed role, but let's do that with this function. So AWS IAM get-role-policy-role-name, and let's put our profile. And policy name, oh, right, let's first list. Whoops, list-role-policies. And this is the inline policy associated with that vulnerable Lambda function. So let's do that. Same thing. Where was it? Get-role and with this policy name. So now we see that these are all the policies associated with this vulnerable Lambda function. We see the IAM attach user policy, which is particularly interesting because this is a super powerful permission. With the attach user policy, you are basically granting this role permissions to attach any kind of permissions to another user. So maybe we could get the administrator privileges from exploiting this function. If we were to somehow assume this role or somehow get the function to give us administrator privileges, then we would have it because this function can do that. On top of that, it also has some S3 permissions, logs, not anything that interesting. We can go back to get objects if this does not work. But let's look into this function here because this definitely has permissions that we don't have with the assumed role. So let's try to invoke this function. So we go AWS Lambda invoke. Recall that we have the permissions to do that. and one moment, AWS Lambda invoke function dash name. So what is the function name? Let's go back and list the function names. Let me clean up a little bit. AWS Lambda list dash functions profile Lambda, and the function name is this. Well, before we even invoke it, we actually have to know what this function even does. So let's get the function first. AWS get dash function Lambda profile Lambda, and put the function name right here. And it returns with this long URL, and what this URL is just the URL to download the source code of this vulnerable function. So right here, we can save it to downloads, sure. And let's move downloads to here. Make dir source and unzip it. So these are the this is the code associated with this function. If we look at main.py, which has the code associated with this function, we see that the function asks for target policies, and it says select policy name from policies where policy name equals whatever the input is, and public equals true. Now they were nice enough to put all these comments here to show what is allowed. So for example, policy name this would be allowed because the public is true. But all of these aren't that interesting. These are just read-only access permissions. What we really want is this administrator access. But unfortunately, it's false. So you see, if this is not a valid policy, if we put a policy that's not valid, such as administrator access, then it says it's not an approved policy. Please only choose from the approved ones. It's because of this public equals true thing. But if we look closely, this looks, just like an SQL statement. And what we could do, if you look here, it looks quite insecure because we can actually break out of these quotation marks by just adding a quotation mark ourselves, just like a basic SQL injection attack. So if we look further down, is there anything interesting? Doesn't seem to be anything else. So let's just put our payload in. So AWS Lambda invoke. Let's put our profile, and we want the function name, and we want the out file. So the function name was that vulnerable. I should really save what the function is called, but we came this far. Okay, here it is. Here's the function name, and we also want the out file. Let's just call it out.txt. And there was an error, unhandled. So let's just cat this. Let's see what it says. It wants a payload, of course. We didn't input any payload. So we could do a payload with the -- payload flag. You could even, if you're ever not sure about how a function works, just type in the function. So for example, this invoke, and then the help function after that. So if we go down to payload, we can see that this is like the format of the payload. But a much better way, a much cleaner way, is to just create a payload file and just invoke the payload from that file. So let's just call it payload.json because everything is in JSON. And we'll say that, well, what did the function want again? It wanted a policy names and a username. So let's put policy policy underscore names. And let's put administrator access. And we can put user underscore name. And let's put our username, which is something really long. There it is. Copy this, paste, and we close. Okay, let's put this in and see what happens. So payload, our file, which is payload.json, and let's see. This time it didn't error out because we actually put a payload in. So let's cat that. It says A is not an approved policy. Please only choose from approved policies and don't cheat. Well, A is the first letter of this policy name. I think it's just enumerating. It's looking for an array. And as you can see, it actually is for policy and target policies. Well, we just inputted a string. So for policy and target policy, policy would be equal to A. And then in the next for loop, it would be D and then M and then I. So let's put that into a list. Just like this. And let's see if it says that same thing. Administrator access is not an approved policy. And that's because it was set to false, if you remember right here. And it only wants something that's true. So let's do that basic SQL injection attack by inputting a single quote and just commenting out the rest. Just like this. And now let's see if that happens. Now, before I even run this, let's quickly just look at what our permissions are for our current Bilbo user. So if we go back to, where was it? Oh, I didn't save the command. Okay, well, AWS IAM get -user -policy. Or first let's list it because I forgot what it was called. Yeah, it's a good idea to save the outputs of your commands so you don't have to constantly do stuff like this. And same thing with the STS. Oh, at least I have that right here. Here's the username. And this is the policy name, so let's get the user policy. And it was policy this, right? Nope. Mistyped. There we go. So these are our current permissions. And one other thing to show before we do this payload is let's look at the attached user policies of profile Bilbo. Now, if you remember, it doesn't have any managed policies. But what we can do is through this function give it a managed policy, just like administrator access. This was the policy name. Here is the username. So, no attached policies. There are no managed policies associated with this user. Administrator access is a managed policy. So let's just put this payload in. And it didn't error out. Let's cat. And it says all managed policies were applied as expected. Well, let's see. If we list the managed policies, we see that we are now the administrator. So we were able to exploit this vulnerable Lambda function because of the bad validation on user input. So right here, it was easy to just put in a single quote. So what we're really seeing here is us typing in administrator access and then a single quote here and then dash dash space dash, which is just a comment in SQL. So basically the SQL statement is seeing just this part right here. Select policy name from policies where policy name equals administrator access. So it's like, okay. It says, okay, here you go. Here's administrator access. And we got the administrator access permissions. So thank you for watching this video. I hope it was helpful in understanding the scenario and also about IAM permissions and their security. It's very important to make sure that when you're creating Lambda functions, especially when a user can invoke it, that all the Lambda functions are secure. Because just because a Lambda function, well, is not an IAM policy, IAM policies is the main security weakness in cloud infrastructures, that doesn't mean that a vulnerable Lambda or that a Lambda function cannot be vulnerable. So thank you for watching this video, and I'll see you in the next one.